Hey everybody, Masora back with you. Today we are going to be talking about the distance formula. So the distance formula is what we use to find the length of a segment with two given endpoints. And the formula you see right here is what you're going to need to copy down because that is the distance formula. It looks really hard. It's really not that bad. So just take a second, pause your video, and go ahead and copy that down. And I'll show you how to work that formula and we'll take a look at some example questions. So the distance formula is equal to the square root of x1 minus x2, the quantity squared, plus y1 minus y2, that quantity squared. So if you think about the steps that you're going to need to do, steps to solve for distance formula, sorry for the background noise. The steps to solve for a distance formula are going to be as follows. We are going to subtract inside the parentheses. We're going to square our answers when we subtract. We will then add, and then we will take the square root. So you will need a calculator of some kind for this. I'm going to pull up just my standard calculator. So again, you're really only going to need subtraction, the squared, your addition, and a square root. So the standard calculator on even your computer will work just fine for this. So let's take a look at some problems here. So when we find the distance between each pair of points, they say to round our answer to the nearest tenth if necessary. So again, like we did with midpoint formula, I'm going to suggest that you go ahead and label your points x1, y1, x2, and y2. So now I'm going to actually slide this whole thing over a little bit. Let's see if we can move that. Yep. We're going to move this over a little bit so we can work over on the side here and have some space. So the distance formula says that we are going to do d equals the square root of x1 minus x2 squared plus y1 minus y2 squared. And then all of that is under one big square root sign. So when we do this, okay, let's do the order that we had said back here on this other screen. We are going to subtract first. So when we go back here to look at these problems, subtract first. -3 minus 3 would give us -6. Don't drop your parentheses just yet. 8 minus 1 will give us 7 squared. So then we've subtracted in the parentheses. Now we will square. The next step is to square. Well, -6 squared, 6 times 6 is 36, and negative times negative becomes positive. 7 squared, 7 times 7 is 49. The next step is to add these two together. Well, 36 plus 49 gets us to 85. And the square root of 85, okay, the last step is to take the square root. This comes out as a decimal. It's approximately 9.2. So that's all the distance formula really is. It's plugging numbers in and working your formula until you've simplified. So let's take a look at number 6. Let's shrink this up and see if we can work number 6 here. So number 6, again, x1, y1, x2, and y2. Just give yourself some labels so you don't lose your order. So the distance here is going to equal -5 minus a -1 squared plus 3 minus 1 squared. Well, we've got double negative signs in here, so don't forget when you get double negative signs, this actually turns into pluses. So now we actually are looking at -5 plus 1. Well, -5 plus 1 is -4 squared. Oops, make sure that's a squared. And 3 minus 1 would give me 2 squared. You'll notice I don't drop my parentheses until I've actually squared something, because -4 squared, well, 4 times 4 would get me 16. 2 squared, 2 times 2 would get me 4. Well, 16 plus 4 is 20. Once I get a single number, I bring my square root bar back down and I use my calculator. And again, when you're checking these in your calculator, so the square root of 20 is 4.47, but they said round it to the 10th place. So because that 7 is going to make this 4 round up, and my answer will be 4.5. Now, when you get into problems where there is a graph, okay, if you're lucky enough to have problems where there's a graph involved, I will show you that the graph actually can make your life a whole lot easier if you let it. Now, not everybody would agree with me on that, but I personally think that graphing with the distance formula becomes a whole lot easier. So let's slide this over so we can take a look. What I want to show you is that with this line segment, what I'm able to do, and I'm going to use a very bright color here. Let's use some yellow. I can actually use the graph to create a nice little, oops, I wanted a bright color, a nice little right triangle. So what I'm going to do is I'm going to start from my top point and I'm going to go over just far enough where I can go straight down until I reach that other point. So what I've done here is I've created this really skinny right triangle. Now, you could do what we did with problems 5 and 6, and you could name the ordered pairs at the ends, do the distance formula like normal. But some people are going to find that to be a little bit time-consuming when you've got several problems to do. So there is a way to get a shorter version of that. If we create this right triangle, okay, what we're going to do is we're going to use a version of what we call the Pythagorean theorem. And we'll get into that in a later section, but I wanted to give you a preview of how it's useful here. So if we take this top endpoint and we try to connect it to the bottom by only using horizontal and vertical lines, how far over did we go? We only went over by 1 unit. If we count how far we went down to get from this edge, this corner, all the way down to the bottom edge here, well, let's count it out. We went 1, 2, 3, 4, 5, 6, 7, 8. We went 8 units vertically, 1 unit horizontally. You can find the distance between these 2 points by doing the following. 1 squared plus 8 squared, squaring each number. 1 squared, 1 times 1 would give me 1. 8 times 8 would get me 64. Add these together, we would get 65. And take the square root of 65. Notice the process. All we're doing is skipping the subtraction step here. We're still doing the squared, we're still doing the adding, and we're still doing the square root. So the process is the same, but we save you a little bit of time in having to worry about the subtraction by just counting the units. So the square root of 65, if we put it in our calculator, the square root on 65 is 8.06. Well, 8.06 is going to round to 8.1 units. So again, the shortcut when you have a graph is to use the graph to create a right triangle. So from the top point, I always say to start from the top point, we are going to go either right or left. You can go in either direction. But our goal is to get to where we are right above this bottom point, the lower point. So I'm going to go straight over, horizontal, and now I'm above that point below it. Now I'm going to drop straight down. So now we just count the units. I went 1, 2, 3, 4 units to the right, and I went 2 units down. So the distance between these two endpoints would be as follows. 4 squared plus 2 squared. Well, 4 squared, 16. 2 squared is 4. Add them together, we get 20. Take the square root on 20, and we end up back at the same thing. We've seen square root of 20 already, 4.5. So you will see that whether you do the formula or if you're given a graph and you do the shortcut formula, either one will work for distance formula. So hopefully that's enough to get you guys rolling on your distance formula questions. If you have any trouble, by all means, send me a picture. Feel free to reach out or come to office hours. Thanks, guys, for watching. We'll see you tomorrow.